Yes, so hi everyone, and welcome back. And today we are having module number 8 of the Global Professional Fellowship in Green Urban Innovation and Social Entrepreneurship. And the module today will be entitled Smart Building and Internet of Things, Transitioning Neighborhood to Renewable Energy and Using Sensors, Data, and Energy Monitoring for Smart Cities Connectivity. And the module today, again, it's being organized by the Global Ambassadors of Sustainability, jointly with the Global Green Chamber of Commerce and the Green University Network at the Kingdom of Saudi Arabia. So now I'm inviting Ms. Michelle Thatcher, the CEO of the Global Green Chamber of Commerce, for the opening remarks. The floor is yours, Michelle.
Thank you, Dr. Bassam, and thank you to our audience for joining us today and our esteemed speakers. As you can see, we have a really impressive lineup, and we encourage you to stay for the entire duration and ask questions and stay involved if you are just joining us now. As Dr. Wassam had mentioned, we're going to be talking about renewable energy and smart connectivity, really looking at key takeaways, about smart buildings and how they drive efficiency. Renewable energy does work better together. Data enables better decisions. People remain the priority within this. These are just a couple of high level key takeaways, but there'll be so many more. And none of this would be important if didn't start taking action. So just a few of the key actions that you'll start to pick up on are about assessing opportunities for energy monitoring. We need to start to explore renewable energy integration and use data for improved decision making and design with both people and sustainability in mind. So thinking about those as you are implementing those within your cities. And as we have been doing for many months now, or about a year and a half, we're going to take one moment of silence to give kindness, strength, and peace out there in the world that is tumultuous at times. So that can be on the international level or in your workspace or at home. So just giving this moment of silence to build up love and strength and peace. And let's extend that to our speakers today. We are so grateful for them to bring their knowledge with us and sharing that so we can build a more sustainable world. And I'm going to pass it over to Hajra, who will provide us with some friendly reminders for our audience today. Hajra.
Thank you. Hi, everyone. Today, we would just encourage your participation. As our speakers give their presentations, you're welcome to share your thoughts and reactions. Please share your location, where you're joining us from today, and then feel free to ask questions. When you're asking questions, make sure to also put the speaker's name so that way we have it organized when we have our Q&A session. This is an open and inclusive, uplifting dialogue, and we're looking forward to everyone's insightful comments and questions coming in today as we bring them into the Q&A session at the end. And I'm going to pass it back to Michelle.
Thank you so much, Hajra. And I'm going to pass it over back to Dr. Wissam, who, with the Global Ambassadors of Sustainability, has brought us all here today and found these incredible speakers. And if you haven't already listen to the past modules, we encourage you to go back and get your certificate for those, and hopefully you'll receive your full certification for the fellowship. But here, back to you, Dr. Wissam.
Yeah, thank you so much, Michelle and Hajra, for the introduction. And now we start with our first guest speaker for today, Dr. Haifa Ibrahim Al Khalifa, And Dr. Haifa, she's the Dean of the College of Engineering at the University of Bahrain, from Bahrain. So the floor is yours, Dr. Haifa, and you have 10 minutes, please.
Thank you so much, Dr. Wissam, and thank you for this invitation. And today I'll present you my study with the title of Exploring IoT Integration, Smart Buildings and Renewable Energy Neighborhoods with a focus on sustainability, resilience, and ethical design in Islamic communities. We'll start by defining what we mean by smart city. So a smart city is an urban environment that uses digital technologies, sensor, data system, the Internet of Things, IoT, artificial intelligence, and communication networks to improve quality of life, urban efficiency, sustainability, governance, and resilience. So a foundational definition explains that a smart city is a city where information and communication technology, ICT, is merged with traditional infrastructure and coordinated through new digital technologies to improve urban systems such as transport, buildings, energy, water, governance, and public services. Another highly cited definition argues that a city becomes a smart when the investment in human capital, social capital, traditional infrastructure, and modern ICT support sustainable economic growth, quality of life, and wise management of natural resources through participatory governance. Therefore, a smart city is not only a technology-based city, it is also a sustainable city, a resilient city, an innovative city, and a human-centered city that improves well-being, equity, safety, and participation. But what actually means to design a smart city? Designing a smart city means creating an urban system where buildings, streets, energy, networks, transportation, water system, public spaces, and community services are digitally connected. In this design, the city function is an integrated ecosystem. Smart buildings monitor energy use, temperature, lighting, air quality, occupancy, and security. IoT sensor collect real-time data. IoT sensors collect real-time data from buildings, street, vehicles, grids, and public spaces. And data platforms help planner, residents, and decision makers understand how the city is performing. Patty describes smart cities as a place where urban data, digital communication, governance, risk management, and infrastructure are connected to solve complex urban problems. Moving on to the next slide, connecting smart cities and how we connect actually smart cities through energy, innovation, resilience, and green urbanism. Energy is very important, and we can, through the data, we found that building operation account for 30% of global final energy consumption and 26% of the global energy-related emissions, according to the International Energy Agency, IEA, 2023. Smart buildings reduce energy waste through automated lighting, occupancy-based cooling and heating, smart meters, energy dashboards, predictive maintenance, and integration with solar panels and battery systems. When it comes to innovation, smart cities use innovation to transform urban management from a reactive model to predictive model. Instead of waiting for energy shortage, infrastructure failure, or traffic congestion, smart city or smart system use data to anticipate problems. And moving to resilience, a resilient smart city can respond to climate change, heat waves, floods, power failure, and population growth. Smart energy systems improve resilience by decentralizing energy production. And finally, what do we mean by green urbanism and connecting to the smart city? Green urbanism actually focuses on designing cities that reduce environmental harm, protect natural resources and improve human well-being. Smart city technologies support green urbanism when they are used to reduce carbon emissions, improve public transport, increase renewable energy, reduce water and energy waste, monitor air quality, and support compact, walkable, and climate-sensitive neighborhoods. But what are the global reasons why why we are moving toward smart and renewable neighborhood? There are many reasons, and we have listed here a few of them, starting from rapid urbanization, energy security, better quality of life, and also responding to climate change and to have more economic efficiency and also to meet the sustainable development goals. All these reasons moved or put a pressure on the communities to move more to smart and renewable neighborhoods. But what are the main goals of smart buildings and IoT in renewable energy neighborhoods? Of course, we know all these reasons and we'll go through them just quickly. One of them is to reduce energy waste and to increase renewable use and to also provide positive energy districts and also to make a decision that is informed by accurate data collected and also to provide citizens with the awareness and also to make the city more connected. So what we have found from the literature review, we have found very important points. One of them is that the smart city research is broad, but sometimes fragmented. So Zhao reviewed smart city research and found that the field is often fragmented and technology driven, with insufficient attention to failed projects, negative impacts, theory development, and empirical testing. IoT is a core technology for smart cities, and this is one of the other findings. Zanella explains that IoT enables the smart city services by connecting sensors, devices, communication networks, and data platform across urban environments. Another findings is that the smart city must be human-centered. That means that smart city should not be measured only by number of technologies they use. They should actually be evaluated according to quality of life, citizen participation, sustainability, social equity, environmental performance, privacy, and trust. One more findings is that the sustainability is essential to smartness. Smart energy is one of the strongest smart city domain. Positive energy and zero emission neighborhoods are growing research areas as a state-of-the-art review found increasing interest in zero emission neighborhoods and positive energy districts. The same review found that the most climate-friendly neighborhood research focuses on energy systems, while social aspects and microclimate issues are less studied. The last finding was about privacy and security, where they are seen or perceived as a major challenges. Smart cities collect large amount of data about movement, energy use, household behavior, location, building occupancy, and service use. Kitchen warns that a smart city data system can make cities more knowable and controllable. But they also raised ethical questions about surveillance, privacy, social sorting, and governance. And moving to the next slide, we will talk here about the smart buildings and IoT and how they work in practice. They work through many tools, through sensors, through smart meters, BMS, data analytics, smart grid and microgrids, and digital twins. All these tools are a summary of many other tools that can be used to create a smart cities. Now we are transitioning the neighborhood to renewable energy, and the transition will be on 3 levels: the building level, the neighborhood level, and the city level. When it comes to the building level, it could be transitioned through installed rooftop solar panel, for example, use smart meters and energy dashboard, improve insulation and passive cooling, install efficient lighting and appliances, use a smart HVAC system, add battery storage where possible, monitor water and electricity consumption, use automated shading and daylight system. And when it comes to the neighborhood level, connect buildings through smart energy network, share renewable energy among homes, school, mosque, community centers, public buildings, and small businesses, use district cooling or heating where climate and density makes it suitable, create local microgrid for energy resilience, monitor public lighting, irrigation, waste systems, electric vehicle charging, and transport energy use. The last level, which is on the city level,
Dr.
integrate.
You have 2 minutes, please.
All right. So I will just skip to the main core of the study, which is how this smart city affect the Islamic communities. So Islamic communities and smart city design should not only focus on technology and efficiency. It should also reflect ethical and social values such as privacy, neighborliness, moderation, and stewardship, justice, protection, and avoiding waste. So this section does not really on direct religion text citation. Instead, it discusses the Islamic urban values as ethical and cultural principles that can guide smart city design. We know that privacy is one of the important principles in Islam, and we should actually, where it's a major, as we said, urbanism Islamic value, and should be also implemented when considering smart urbanism. So I will move to the finding. Right. I will move here to the ethical framework for a smart city Islamic neighborhood. As we said, there are many principles to consider. One of them is privacy, neighborliness, resilience, transparency, participation, moderation, and justice. I will conclude here with the suggested academic argument by saying that smart buildings and IoT enable energy monitoring are central to the transition toward renewable energy neighborhood because they cannot physically infrastructure because they connect physical infrastructure with the real-time data, enabling cities to reduce energy waste, integrate renewable resources, and improve resilience. In Islamic communities, smart city design can align strongly with Islamic values such as privacy, the principle of neighborliness, stewardship, moderation, avoiding waste, and others principles. Therefore, the smart Islamic neighborhood can represent a model where innovation, renewable energy, green urbanism, resilience, and moral responsibility work together. Thank you so much.
Thank you so much, Dr. Haifa, for this interesting presentation. And now we'll move to the next guest speaker, Mr. Rafael Brisina. And Mr. Rafael, he's a global executive sustainability leader from Spain. So the floor is yours, Mr. Rafael, and you have 10 minutes, please.
Thank you so much, Dr. Wazam, and thank you for the members that are participating in this presentation. My presentation is about smart buildings and Internet of Things in green urban innovation. The concept that was described by my previous speaker also is the vision of green urban cities. Innovation represents a revolutionary shift in city planning, integrating state-of-the-art technology with eco-friendly infrastructure, focusing on ecological integration, resource efficiency, and human-centric design. The concept of smart city Internet of Things connectivity, we have three main venues that are the nerve system, the edge computing, and unified platforms. All these are interconnected in cities with different buildings, energy suppliers, water plants, and through the grid. Resilient urban infrastructure, the nature-based architecture, contemporary architecture is in smart cities evolves from static buildings into responsive structures that adapt to their environment. You can see here that we have three key areas that are building integrated photovoltaics can be installed in facades and glass surface to generate energy on site, permeable surface for rainwater harvesting and smart irrigation to manage urban flooding, and heat island mitigation, vertical forests and green roofs to help lower ambient temperatures in urban areas. AI and autonomous robotics in green urbanism, they have two key areas: predictive and cognitive AI, the digital brain that is uh, divided by dynamics grid balance, intelligence traffic and emissions route, and predictive resource conservation. And the autonomous robotic systems, the physical infrastructure, autonomous waste sorting and recycling hubs, drone-based living wall maintenance, and automated environment auditing. The convergence of AI and robotics for sustainable cities, we can describe it for energy optimization, real-time AI analytics reduce energy waste and improve renewable energy integration, sustainable infrastructure management, robotics minimizes human exposure to hazardous tasks and enhance resilience. And environmental intelligence, autonomous monitoring enables rapid sustainability interventions and climate adaptation. Circular economy acceleration, robotics recycling systems improve material recovery and optimize waste logistics. And the future urban vision, self-regulating districts, AI-managed mobility systems, and robotics-enabled climate resilience. So here I'm going to present a case study that is my main focus expert. This is Green Buildings case study related to the hospitality industry. As you know, the hospitality industry works 260 days a year, then 24 hours a day. So it's a very intensive industry, and I will show you why. The energy challenge. Why hospitality must act now? High intensity operations. As I described in my previous slides, hospitality operates 24/7 among of the most energy intensive commercial sectors. Energy costs represent up to 6% of total operation expenses for full service hotels. HVAC systems, lighting, hot water heating account for 70% of energy consumption. And you see that 6% of hotel revenue spent on energy is the second most energy intensive commercial sector worldwide. And the annual US hotel energy spend accounts for $6 billion. The smart building ecosystem, integration of sensors, automation, and real-time analytics. Why is this important? Because the smart city networks and utilities, they interconnect with open APIs, demand response, and municipal platforms such as Beam or ECAP. Building management systems, centralized controls of HVAC systems, lighting, access, and alarms, edge computing, AI analytics, local data processing in less than 10 milliseconds automation response time, and IoT sensors and connected devices. They track occupancy, temperature, leaks, CO2 emissions, energy meters, and smart locks. Real-time IoT represents an important advantage because all the systems are interconnected and communicate in a unified IoT platform. Edge computing enables real-time HVAC systems automation and reduce the bandwidth cost by 60 to 80%, and predictive AI predicts maintenance cost downtime by 30%. Here are some areas for strategic applications where sensors and automations deliver measurable hotel savings. Uh, in climate control, all weathers integration, preconditioned rooms before check-in, multi-zone HVAC systems controls and reduces energy waste and unoccupied areas, and CO2 sensors triggers fresh air ventilation only when needed. Water management, as well as smart irrigation systems, adjust real-time weather conditions, and low-flow fixtures monitoring track consumption at fixture levels. As I mentioned, energy monitoring through BMS, building management systems, dashboards display electricity and gas in real time, submetering by room, floor, and systems pinpoints water sources, and they can detect anomalies. And Energy Star Portfolio Manager, there's a free tool in the US of the EPA, integrates data for compliance and reporting. Here in this graph, you can see a breakdown where hotel energy goes and where smart systems have most impact. HVAC system 30%, smart savings between 20 and 30% with smart controls. Water 24.8% with saving between 15 and 25%. Food, F&B, food and beverage, 20% smart savings, 10 and 50% with IoT monitoring for food waste. Lighting, 7%. Smart meters, they can go up to 62% with LED and sensors, and our systems, 17%. Renewable energy system and synergy, you can generate renewable energy on site with PV solar panels that provides 80 to 30% of hotel energy mix, building integrated photovoltaics on facades and glass, geothermal on or micro wind turbines, storage, battery storage for storage and grid flexibility. And here you can find some industry benchmarks and green procurement, such as PPAs and renewable energy certificates, community solar subscriptions, and utility green tariffs. Here is a business case study for smart tech. If you apply traditional operations, you have a cost of $2,150, and with Internet of Things, you can have a cost of $1,537. The payback period is between 3 to 5 years, energy cost reduction between 20 to 40%, maintenance savings between 10 to 25%, BPS fine avoidance up to $1 million in some properties, and guest satisfaction lifts by 12 points. Here is this slide represents how you can, with your smartphone, you can have a hyper personalization of a room. Internet of Things as an engine of guest experience and brand loyalty, mobile and voice control, guest profile intelligence, and sustainability engagement. Operational KPIs, documented performance outcomes from Internet of Things enable hotel developments. 30% total energy reduction, automated efficiency, a
Yeah.
real-time monitoring.
Sorry, you have 2 minutes, please.
Okay, 62, thank you, percent savings and 25% HVAC optimization and 40% water reduction, leak detection, and smart irrigation systems. And this slide represents the comparison between the legacy building and an IoT smart building. Maintenance reactive compared to predictive AI driven alerts before failure, energy monitoring, monthly utility bills only, real time per room and per system data, static, manual, and override, occupancy, weather, and AI response, guest personalization, app, voice, and profile integration, water management, live leak detection and smart irrigations, reporting and compliance, BPS and Air Star Sync, and lighting, occupancy sensors, and daylight harvesting. There are some challenges related to cybersecurity, initial capital expenditures, legacy integration, and operational change management. And the conclusion is that the future hospitality buildings that can be applied also for any type of building is data driven and sustainable. The first one, real time prediction operations. The second, connecting and intelligence infrastructure. And the third one, sustainability use as a competitive advantage. Thank you so much. And I would like to receive any questions.
Yeah, thank you so much, Mr. Rafael, for this interesting presentation. And now we move to the third speaker, Miss Varsha Harik. And Miss Varsha, she's an energy and transition and sustainability strategist from Trinidad and Tobago. So the floor is yours, Miss Varsha. And
Thank
you have
you,
to take
Dr.
15 minutes,
Almadoon.
please.
Good morning, good afternoon, good evening, everyone. Thank you to Dr. Almadoon and to Ms. Thatcher for allowing me to speak today. It's an honor to be here today, and I'll get straight into things. I would also like to thank my two predecessors for giving very good and valuable information. So I'm demonstrating, it's not related to specific case studies, very generic on how smart buildings and the Internet of Technologies are helping us transition toward more resilient, energy efficient, low carbon communities and ultimately support the development of smart cities. These four pillars of smart building ecosystems are built on first the Internet of Things connectivity. Sensors continuously collect the information on temperature, occupancy, lighting, energy consumption, air quality, and of course, equipment performance. Second, renewable energy integration. So buildings are not just simply consumers of electricity. Increasingly, they are becoming producers through the rooftop solar systems, as mentioned by our predecessor speakers. Battery storage, and distributed energy resources. Third, the data analytics and artificial intelligence. So, data itself has little value, but the real value emerges when data becomes intelligence that supports better decision making. Finally, smart city grid connectivity. So, individual buildings and homes become part of a broader ecosystem that includes transportation systems, utilities, emergency services, and community infrastructure. I'll speak about the sustainability initiatives for buildings. So we've heard in the previous modules about what buildings mean in terms of the construction, the energy usage, the raw materials, water, etc. Not just from construction, but also from the operations and maintenance of buildings. Globally, buildings account for approximately 40% of energy demand, 42% of the water consumption, 50% of raw material use. And approximately 80% of buildings' environmental footprint occurs during its operation. So this means that the decisions we make today regarding energy systems, controls, and building management will influence environmental performance for decades. Therefore, sustainable buildings is also an environmental responsibility, so strategic investment is required. In net zero building, of course, the future of construction is shifting from just the energy consumption to energy producing buildings. And to achieve net zero buildings, that means that the energy balance annually has to, balance where the consumption is offset by perhaps renewable energy integration. And to achieve this, we combine passive design, electrification, renewable energy, battery storage, as well as grid flexibility. I know the previous speaker mentioned, the use of robotics, and I'm also speaking about what AI and prefabrication using the digital construction tools can also, um, you know, yield. Holistic design for buildings. So one of the most important lessons in sustainability is that systems cannot be optimized in isolation. High performance buildings require an integrated thinking approach. The orientation of a building influences the solar gain, the landscaping, affects cooling loads, daylighting impacts the lighting demand, and of course, ventilation influences indoor air quality and occupant health. The most successful sustainable buildings are designed as interconnected systems, and holistic design creates buildings that are healthier, more efficient, resilient, and of course, comfortable for occupants. The Internet of Things, sensors, and smart connectivity. So every smart building has sensors. Think of sensors as the eyes, the ears, and nervous system of a building, and they continuously monitor temperature, humidity, air quality, occupancy, the energy consumption, security conditions. There are today around 21 billion IoT devices connected worldwide. And through the smart controls, organizations are achieving up to 30% energy savings and up to 40% reductions in carbon emissions. The renewable energy transition, as we know, is much needed more than ever, considering what we are facing in today's globe, the climate crisis, and there is an emerging, very severe El Nino approaching. So historically, communities depended on the centralized fossil use generation. Now we have the distributed rooftop solar, as mentioned before, the battery storage, community microgrids, demand response systems, peer to peer energy trading. Smart neighborhoods can now generate, store, share, and also manage energy locally. And this creates greater resilience, especially during outages, and reduces emissions, strengthening energy security. And for us in the Caribbean, small island developing states, these technologies present tremendous opportunities to improve the resilience while advancing sustainability goals. Data intelligence is important, as there's a saying, data is the new oil, but only if it is refined. So therefore, smart buildings generate enormous amounts of information. However, information alone does not create value. The analytics transforms data into action. Predictive maintenance can identify failures before they occur. AI can optimize the HVAC schedules, benchmarking can also identify inefficiencies. The automated alerts can prevent energy waste. The goal is to move from reactive management to predictive management. And instead of fixing problems after they happen, we anticipate and prevent them. Smart buildings are just one piece of a much larger vision. Imagine a city where buildings can communicate with the grid. Electric vehicles charge when renewable energy is abundant. Waste collection routes optimize themselves. Emergency services receive real time information during disasters. And this is the power of smart city integration. It creates efficiencies across entire communities while reducing the environmental impacts and, of course, improve the quality of lives. This is somewhat of an implementation roadmap. So, the transformation, of course, does not just happen overnight. Successful implementation requires a phased approach. First, establish the baseline. Second, deploy the connect technologies. Third, optimize through analytics and renewable integration. Finally, scale and continuously improve. And of course, nothing is efficient without proper technology and standards. So, for example, the ASHRAE 90.1 drives energy efficiency. 135 BACnet enables communication between devices. So BACnet, building automation and controls. And 189.1 supports the high performance green buildings. These standards ensure that smart buildings are not only innovative, but are also effective and measurable and sustained. So I'm just going to speak a bit about building automation and control systems. And these are where there's an integration of the different types of controls. You have the closed loop systems, the open loop systems. I will not go into all of these details because it may I may run out of time, but I just wanted to, quickly touch on why they are important. And if we were to consider also the different types of signals, so for example, in the key control terminologies, you have your set points, you have the measured values, if there's an error, the deadband, the differential, the gain. And moving on to uh, the different types of proportional, integral, and derivative controls as well. These are what the outputs give and the signals. So, for example, if we were considering proportional, this is the corrective action for the size of the error. For it's best for, but fast for imprecise, sufficient for non-critical tolerance systems. The integral, it's best for it eliminates a steady state offset. Most building HVAC uses the P and the I, so proportional and integral. And lastly, the derivative. So it's precise control systems, often not needed for slow changing HVAC. Hardware architecture linking sensors, actuators, controllers, and building management. So you have your direct digital control, your BAS versus your control system. So BAS is your building automation system. So the controller in the DDC receives sensor inputs and sends output signals in digital packets over the data bus, that is, and different DDCs are networked together. The advantages are easy to reprogram after installation, the instantaneous responses, so no recalibration is required, and very precise and accurate. While the BAS now, these control systems, they run the HVAC equipment, a subset of the BAS, and it's capable of operating independently. The BAS itself automates control systems and adds lighting, metering, access control, CCTV, fire alarm, and energy management. The benefit of this is it visualizes and manages all building systems from a central workstation with remote access, creating
Sorry,
measurable energy
Ms.
savings.
Basha, you have 2 minutes, please.
Okay, sure. Thank you. Okay, so with regards to the ASHRAE 135 backnet, it allows for oversight on HVAC control and optimization, lighting control systems, fire and life safety systems, physical access control, energy management and metering, elevator monitoring systems. And the saving strategies include a schedule versus optimized start stop, hot water and chilled water reset, static pressure reset, the demand control ventilation, economize on free cooling, additional BAS strategies. Okay, so we are living in a data-driven world, and this is overlaid on engineering-driven BAS HVAC world platforms. So, the smart BAS convergence is definitely something that must be considered. And a typical AI overlay architect includes the wireless indoor sensors, temperature, humidity, carbon dioxide, weather forecast, and local impact data, as well as energy meters and hourly pricing, demand responses, and peak capacity hours. The outcome would give a substantial reduction in heating, fuel, as well as electricity costs, and overall, your reduction in emissions. So, lastly, I would like to say that building a sustainable future together is much needed. So, the combination, or I should say, integration of the Internet of Things, smart buildings, the design for the environment principles, and green certifications yields a net zero community. So, lastly, I would like to say that today we are facing unprecedented challenges. As you know, the climate crisis, resource constraints, urbanization, security, energy security constraints. Therefore, smart buildings are not simply about the technology, they're about people, about creating healthier communities, and of course, reducing the environmental impacts. As we move forward, let's just remember that every sensor installed, every kilowatt hour saved, and every renewable energy system deployed, every intelligent decision we make brings us one step closer to a cleaner, smarter, and more sustainable world. Thank you.
Yeah, thank you so much, Ms. Barsha, for these sharings. And now we move to the next guest speaker, Dr. Khulud Ali. And Dr. Khulud, she is an assistant professor of architecture and sustainability from Brazil. So the floor is yours, Dr. Khulud, and you have 10 minutes, please.
Okay, thank you so much. Actually, today my work focuses on artificial intelligence in architecture, and I would like to introduce a concept that honestly moves beyond individual smart buildings towards something a bit much bigger, the Internet of Buildings. So, this talk explores how buildings can become intelligent. Connected systems that communicate with one another, integrate renewable energy, share data, optimize performance, and contribute to smarter, more sustainable neighborhood and cities. Well, before discussing technologies, I would like to ask a simple question. What if buildings could think, communicate, and care for the communities around them? So, for decades, buildings remained passive objects. Like more recently, we can see that they became smarter, capable of sensing and like automation, right? But the next transformation, I think it's going to be like much bigger than that. So we are moving toward intelligent neighborhoods. Buildings can collaborate, exchange energy, learn from behavior, and of course adapt to environmental challenge. So okay, let me start with an example. Imagine a several hospitals connected through the Internet of Buildings. So instead of working alone, hospitals can securely share live information with like other healthcare facilities across the city. So they can exchange real-time data about available beds, emergency capacity, block types, and medical supplies. Of course, at the end, maybe they can like share the urgent patient needs as well. So they can also monitor early sign of virus spread by comparing health data across different districts, for example. This way we can see that the city is going to be allowed to identify risk areas, predict community outbreaks, and respond faster before the situation become critical. In this way, connected hospitals become part of the intelligent urban health network, and that they can connect both patients and the wider community. Okay, so here I can see that buildings are not just structures. They are like among the biggest energy consumers globally. Heating, cooling, lighting, equipment consume enormous amount of electricity. So at the same time, of course, cities are growing rapidly. So the climate change is increasing pressure on our energy system. And traditional buildings operate passively, following fixed schedule regardless of actual needs. So in this case, that is going to lead to results in waste, but smart technologies provide an opportunity to improve efficiency by making buildings responsive to real-time conditions. And in this way, they can reduce unnecessary energy, and they can support the renewable integration. Uh, well, a smart building is useful, but it often works in an individual way. So it may control lighting or cooling, but it rarely interacts with surrounding buildings. So when we have the Internet of Building, this is going to be totally changed. It's going to be, instead of isolated intelligence buildings, become connected systems. The Internet of Buildings works through a continuous cycle of sensing, learning, and action. Sensors collect data about occupancy, temperature, air quality, and energy use. So this information is processed through cloud platforms and analyzed using artificial intelligence. So the system then makes decision automatically, right? So, for example, they can adjust cooling, lighting, or ventilation. The important thing here is that this process occurs in a continuous way, allowing building to learn and improve over time. And here, the artificial intelligence is is going to be like the brain of the Internet of Buildings, of course. It analyzes patterns, predict energy demand, and continuously improves performance. So another important concept is the digital twin. I would like to say that the digital twin is a virtual model of the building itself and that updates in real time using sensors and data. And this allows operators to test strategies before applying them physically. And this is going to, of course, improve both the energy efficiency and the occupant comfort, right? Uh, well, the Internet of Building as well here, as you can see, is not theoretical anymore, right? As an example, master city buildings are designed to optimize energy and environmental performance using the intelligent technologies. Another example, in the United States, we can see that neighborhoods microgrids already allow communities to share renewable energy and improve resilience. Singapore, on the other hand, also demonstrates how buildings can become a part of a broader smart building system. So these examples show that the Internet of Building is already there, you know. Well, despite its promise, the Internet of Buildings also introduces serious challenges. More connected systems, it means that greater cybersecurity risk. Privacy become critical when buildings collect personal information. Different technologies often struggle to communicate with each other, and limiting, of course, the effectiveness. Finally, governance questions emerge. Well, who controls the data and who benefits from these systems, right? These challenges, actually, we need to address these challenges to make sure that trust and responsible adoption is there. Okay, so, well, imagine a neighborhood where buildings continuously communicate. Energy is shared in an intelligent way, and systems adapt automatically to both human needs and environmental conditions. So buildings will no longer be isolated structure, but active participants in urban sustainability. And the future of cities may not depend on smart buildings alone, but on intelligent neighborhoods capable of learning, adapting, and collaborating. Gonna finalize here. I would say that as a member of the Organization for Women in Science for a Developing World, and as we imagine intelligent neighborhoods and connected cities, we must also ask how will shape these futures. Technology alone, in my point of view, is not enough. Cities reflect the value, of course, of those who design them. And women play an increasingly important role in architecture, sustainability, artificial intelligence, and urban planning. Their perspectives strengthen the innovation, equity, and resilience. Uh, the cities of tomorrow should not only be intelligent but inclusive as well, reflecting the creativity, expertise, and leadership of women. Thank you very much for your attention. I hope that I didn't use more than I should use in time. I hope this presentation offered a new perspective on the future of intelligent buildings and connected neighborhoods. And I would be very happy to continue the discussion and connect it through the LinkedIn. I welcome your questions and thank you again for this opportunity.
Yeah, thank you so much, Dr. Khulud, for the presentation and also for keeping the presentation on time. And now we move to the next speaker, Dr. Yusra Chatuki. And Dr. Yusra, she's a speaker and author and a professor at Al Akhawain University in Morocco. So the floor is yours, Dr. Yusra, and you have 10 minutes, please.
Thank you, Dr. Wissam. Thank you for the invitation. So I appreciate the talks of my colleagues. All the speakers have mentioned IoT and edge and AI related to the solutions. My talk is to go deeper to show what is behind these integration. They are all possible by using efficient use of machine learning, which is my area of expertise. So I will show the aspect of where machine learning comes into play when we are thinking about sustainable urban cities. So 60%, a majority of humans live in cities. So it is in the global benefit to take this seriously and explore all the opportunities that machine learning offers us. So cities consume 78% of the global energy. We have issues such as traffic congestion, which cost cities 310 billion annually in loss of productivity, which most of us we may not think about or be aware of. And also we have the well-known issue of water scarcity, which means that there is misuse or an important water waste when it comes to water management. So machine learning urban systems, we talk mainly, some of these have already been mentioned by my colleagues, but I will go a little bit deeper on how it works in the background. So real-time monitoring and sensing, a lot of the tasks that are managed by humans should be automated, which will reduce the work time and then also make it more efficient. Predictive analytics and forecasting. So when we collect data, which means that we have the most valuable and important things for accurate predictions and therefore assess the needs efficiently. And then optimization and autonomous control. So how do we keep control of everything that was mentioned by the colleagues, whether it's hospitality buildings or smart buildings or internet buildings or even open spaces. So the current challenge is that renewable energy is intermittent, which means that the demand fluctuates. This is where prediction comes in crucial. So the challenge is to keep track and assess before we are in the need or before we have an extra of energy. Building accounts for 32% of global energy consumption, and matching the supply and demand in real time is complex without intelligence. So which means we do need the use of machine learning to do the prediction efficiently. So smart energy management. So machine learning applications, they go from energy management, water resources management, and then in agriculture and other fields, as you will see next. So demand of forecasting and load balances, we have very, very efficient algorithms that have shown more than 95% of accuracy in terms of giving accurate predictions, forecasting, and then load balancing. So building energy management systems. So machine learning models have shown efficiency in learning the occupancy patterns and optimizing HVAC, lighting, cooling systems, etc. And therefore, this could be implemented in any type of buildings, and it will adjust accordingly. The last one, renewable energy in forecasting. For sure, this is very much needed, and we do have things like solar irradiance, wind speed prediction to improve the integration of renewable resources. Last, do we have some real world impact? Yes, we do have the Google's DeepMind. These are real cases and solutions that do exist and can be efficiently implemented to smaller or larger scales. So smart energy management, microgrids, and then we have smart grids and then microgrids. So depending on the scale, are we talking about building a campus or are we talking about a whole city? What is the scale? Of course, they work together, so we would need to combine these. So microgrids, for them to work efficiently, they need to be optimized, which means they will be managed by machine learning, collect data from these microgrids and smart grids, and then deploy them into machine learning models to train them on them, and therefore improve the prediction and the management and automate the detection of anomalies, etc., failures, etc. Machine learning applications. Do we have some case studies? I was happy to see Dr. Khuluz mention Singapore and other cities. Yes, the scenario of Singapore is one of the good examples that could be followed. Some of the really optimistic results that they already achieved is the 420 tons of CO2 emissions prevented annually, and then 50 million in energy cost savings. So they do have a platform extensibility to include EV charging and water systems and waste management. So this is doable and very much achievable and could be implemented everywhere around the world. So next is traffic. I mentioned in the beginning traffic congestion and what it costs in terms of work productivity around the world. The challenge is how can we reduce these CO2 emissions produced by traffic congestion and then reduce the number of hours that are wasted. So what does machine learning offer us is adaptive traffic signal controls. So we can use reinforcement learning algorithm to control signal timing in real time. Therefore, you would not have somebody waiting a red light if the roads are empty, for example. This results in 20 to 30% reduction in wait time, 10 to 15% of emission reduction. And there are some examples where this is implemented in Greece, in USA, Copenhagen, in some cities, okay? So intelligent routing and trip planning, rerouting, so that it's the prediction and the forecasting helps us in managing the rewriting of traffic to ensure that there is a smooth traffic and then reduce the traffic congestion. Do we have some existing solutions? Yes, we have integration with the navigation apps widely used, Google Maps and Waze, and these impact millions of users everywhere around the world. So the demand of prediction and congestion forecasting, we do have time series models that can predict these bottlenecks hours in advance, ahead of time, and therefore decide the rerouting accordingly. Enable proactive measures, opening additional transit capacity, pricing adjustments, or even rescheduling. And of course, it improves the response rerouting. Intelligent transportation and mobility, of course, this could be mapped to public transportation and therefore improve the citizens' experience. As we know, public transportation runs 24 hours, and therefore it has a larger impact of CO2 emissions. We want to run that efficiently, and therefore we'll have immediate results. So the machine learning algorithm optimize the bus metro routes and schedules based on real-time demand. So these predictive models can identify the underutilized routes and enable dynamic routing. So even the use and the assignments and the timings will be detected, predicted, and will be recommended by the machine learning models instead of a human. Where therefore we will see an immediate result, as I mentioned. Hopefully it's at least a 15 to 25% operational cost reduction, improved accessibility, etc. An existing real case successful story is the Barcelona smart mobility system. And I'm happy to see one of our colleagues is from Spain. So the context is the Mediterranean city with 1.6 billion residents, and we have a number of these cities around the world. Heavy tourism, 32 million visitors annually. So all of these tourists are not familiar with this city and will need access to transportation efficiently. So where does machine learning help? Machine learning offers real-time traffic analysis, using computer vision. So all of this is based on neural networks. It monitors more than 800 traffic cameras to detect congestion and incidents. So this could be reported even when there are cases of accidents with the local authorities. Adaptive signal control, we have reinforcement learning algorithms that optimize more than 1,200 traffic lights, reducing congestion dynamically. So next, what is next? we can see that there is a scalability lessons, and this could be upscaled to either larger or to smaller. Waste management. Waste is gold. It should be reused, whether we're talking about water waste or any type of waste. And we know some countries that have become famous for this. 1.3 billion tons of waste generated annually, and only 35% is properly managed. So there is a lot of opportunity there. So what can machine learning help us with? Well, initially from optimized collection routes, the collection in itself, which will help with the CO2 emissions as well. So route optimization algorithm will analyze bin fill listen level sensors. So which means it will only go to bins that needs an actual collection. Machine learning models predicts when bins will be full and will avoid unnecessary trips. So this will impact 30 to 40% fuel saving, reduced emissions, and lower costs. Real-time rerouting response to changing conditions, of course, and will adjust accordingly. And then next is the smart waste sorting and computer vision, something that we don't want humans to be doing. It is more efficient for the machine to take care of. Machine learning can also help with material flow prediction and demand forecasting, and also can be used to detect illegal dumping detection, especially in larger cities or sides of the cities. So more into waste management, we have what is called circular economy. So how can we manage landfill gas monitoring, for example, and methane capture, hazardous waste tracking, and safety to ensure that no hazardous waste goes into our water resources or natural resources.
Sorry, Dr. Yusra,
Yes,
you
I will
have 1 minute. 1 minute, please.
All right, I will include with this entrepreneurial opportunities. All of these offer us opportunities for businesses to invest, whether it's waste optimization software platform, robotic sorting system design and deployment, sorry, landfill gas monitoring management, circular supply chain. The last is Amsterdam Circular Economy Initiative. I invite you to look it up. It is one of the really good success stories that I am happy to share with you. Last, to implement machine learning, what do we need? Smart collection, AI-powered sorting, waste prediction, circular design platform, and landfill biogas. And this is an image of what it should look like. The results, we should be able to have an actual results that we can identify and feel immediately. Waste, landfill, recycling, money saving, job creation, all of that. Okay, I jump to Singapore is another really good success story when it comes to using machine learning for water management from the sources. Water demand forecasting, quality monitoring. We have, again, very efficient models that have helped with that, offer solutions. I will skip all the way to natural resources. So from natural resources all the way to our water tap, to our drinking water, etc. I will skip to the last one. So the challenges and solutions, which is what I will conclude with, ethics, which is what my colleagues have mentioned, governance. We need the political decision makers to make the decision to adopt machine learning integration in an ethical and responsible way within our cities. Otherwise, this will not be feasible. The other challenges is cities lack ML engineers, so we need the right training for people to be able to implement machine learning efficiently. So it should be included in all types of engineering courses, etc. Bias and fairness is a well-known issue with machine learning, so it should be taken in consideration. With that, I will conclude, and you have my contact, and I'll be very happy to discuss this further. Thank you very much.
Thank you so much, Dr. Yusra. And now we move to the last speaker, Mr. Eric Appiah. And Mr. Eric, he's a cybersecurity and AI governance specialist, and also ESG sustainability tech. And Mr. Eric, he's from Ghana. So the floor is yours, Mr. Eric, and you have 10 minutes, please.
All right. Thank you so much for the opportunity, global sustainability. And then also a big thank you to the Global Green Chamber of Commerce. Today, what I want to talk about is how African cities are building resilient and connected sustainable communities. So I want to talk on the side of Africa. All right, this is going to be my outline. So the African urban future is being built now. There are a lot of African countries that are building smart cities. Why is that important? You realize that Africa has, how do you call it, outdated, a bit of poor infrastructure that needs to be rebuilt. Okay. Another point is also because the city is highly vulnerable to flooding. A typical example is the recent, flooding occurring in our cities. For example, Accra. It rained heavily yesterday. It has been raining for the past month, and a lot of flooding is occurring over here. And so what does this mean? This means that it really applies to us as the vulnerable people with regards to how these things are supposed to be done. And it is also important because more than 600 million Africans are still lacking electricity access. And so we are saying that how can Africa build cities that are smart, green, resilient, affordable, and inclusive? All right. Okay, so what smart buildings mean in Africa? Right, we are talking about the fact that a smart building can help us with IoT sensors, to be able to do monitoring and measure with the smart meters. It also includes automated systems and AI-driven monitoring, and then renewable energy systems. What this means is that we'll be able to monitor our energy usage when there is heavy energy being used, and then it will also help us to optimize our energy usage and all of that, water, waste, and then electricity. So these things are very important in helping us to use energy efficiently, reduce costs. According to research, IoT Smart can help us to reduce costs by 30%, climate adaptation, and then urban resilience. That has to do with the vulnerable cities. Okay, so Africa's renewable energy momentum, you can see that South Africa is on top of the chart because South Africa is doing really well with regards to adding solar capacity and the momentum that the solar revolution. And you can see overall, Africa is doing well with solar. If talking about solar, we are now adopting electric vehicles, and there is so many, the influx of aircraft, particularly, it's now we are using electric vehicles, electric motors for delivery. You can see them everywhere, and this is a good thing because there was over reliance on hydroelectric energy. What is the role of IoT in African cities? So IoT will help us to, use the smart electricity meters, the environmental sensors. The environmental sensors is particularly important because we are an agriculture-based economy. And what that means is that we will be able to use these sensors to monitor things that go on in the farm, crops, and all of that to be able to help us with increased yields. And then smart traffic systems, smart water monitoring, very important. For example, when there is a leakage, for instance, nothing happens. The water will leak, and then it will cause wastage. It will take someone to notice, and it will even take a very long time when it is reported to the water company for them to fix it. And so if there is a smart water monitoring, these things can be alerted and be fixed instantly or within the shortest possible of time. And then intelligent lighting. So I would want to talk about this much more because I don't understand why we are living in 2026. And then when there is an issue with our major source of power, the whole city goes black. It is something that must be really looked at, smart waste systems. And this can help us reduce energy wastage, lower operational costs, and then real-time decision making. Now let's look at the case studies across Africa. So in Kenya, we have Konja Technopolis. So this is a smart city project under Vision 2030 that is designed to have all the smart, tools, smart, resilient, to build resilient city. The infrastructure features fiber connected infrastructure, smart utility systems, IoT systems, intelligent traffic systems, and renewable energy integration. They are purely going on solar, which is a very good thing. It is also projected to generate 200,000 jobs, and a very big thank you to Kenya for this. What are the lessons to learn? Hard infrastructure. We also have smart human capital. They really need skilled people to be able to, when it comes to machine learning, IT, tech, and all of those things. Key challenges has been attracting private investors and then infrastructure financing. And let's also look at Nigeria. Nigeria is also doing very well with Eco Atlantic. So it's an ambitious smart city project. They want to do everything, like they want to have 24/7 independent power from the national grid, underground drainage, fiber optic connectivity, and centralized wastewater. I am particularly interested in this project because of the independent power, where it has to do with purely backed by the renewable energy. So they are going to integrate renewable energy and smart grid integration, such as smart metering system, SCADA, predictive, and scalable infrastructure. I'm very interested in this project. They are doing so well. They also have similar challenges. However, the independent 24-power smart grid with solar, I really like that. I've indicated. They are looking for 300,000 residents to settle at the place. And this is a very good project that must be. So and let's also look at South Africa. They are leading with regards to the renewable energy market. They added 10 gigawatts of solar capacity, doing a lot with regards to energy, solar energy. And why South Africa matters, they are building a lot of smart grids, renewable integration, battery energy storage, and intelligent energy systems. Okay, a broader lesson for Africa from South Africa: smart energy infrastructure is no longer optional in Africa. It is becoming essential for economic stability. All right, so let's look at Rwanda, smart and green planet. Rwanda is also doing a very good project with regards to the smart city and the renewable energy. So Rwanda's approach has to do with digital governance, green urban planning, smart mobility, IT infrastructure, and clean energy systems. Their focus areas have been efficient public services, environmental sustainability, smart
Mr. Eric,
transport. Yes, please.
you have 1 minute, please.
All right. Now, so smart buildings and energy monitoring. So data is the backbone of smart cities. So the benefit is reduced energy costs, predictive maintenance, lower emissions, efficient cooling systems, reduced waste. And why resilience matters for Africa. I've mentioned the flooding, the drought, the heat, the coastal erosion, and then infrastructure collapse. We are the vulnerable people, and these things are very important for us. Key challenges facing Africa, we have infrastructure financing, the digital device, the cybersecurity risk that has already been mentioned, the policy and governance gaps as well. It also presents an important opportunity for entrepreneurs who want to go into clean energy, smart agriculture, and urban innovation. Thank you.
Yeah, thank you so much, Mr. Eric, for the interesting presentation. And now um, I will invite Ms. Michelle to moderate the Q&A session. So the floor is yours, Michelle.
Thank you, Dr. Sam, and thank you to our speakers today. So informative, and I know we're always tight on time here, so appreciate the respect for each presentation that we have and all the questions that are coming in. I'll also have Hajra help me. She is our International Sustainable Policy Manager and has been helping to collect some of the questions on the back end. We will jump right into questions. I'm going to start with Dr. Haifa. Our first question is from Dr. Indira Bunik from Switzerland, and she asks, smart building technologies are evolving rapidly, from passive design to AI integrated systems. In your view, what is the single most transformative smart building innovation that Gulf cities should be prioritizing right now?
Right. So I think the most important innovation that the Gulf City should prioritize is the energy management system, where this system can predict, monitor energy, and also providing adjustment to lighting, cooling, heating. So this is the most important, I think, solution, AI solutions to be provided for these communities.
Thank you so much, and thank you for keeping answers short. I forgot to mention that if we can keep answers to around 1 minute or less, that would be great. And I'm going to pass it over to Hajra to ask Mr. Raphael the next question.
Perfect. So for Mr. Raphael, this question is by Dr. Engineer Noel, and they are asking, what are the key strategies to ensure full engagement of communities and their daily operations?
The first one is to engage with all stakeholders and to have a common vision of where do you want to go. And that is a strategy that is based on from the top level all the way down to all the stakeholders and community members.
Thank you so much, Mr. Raphael. And our next question will be for Ms. Barsha. And we have a question from Zohir. And he asks, how can digital twins, AI, and IoT work together to optimize energy consumption across a smart neighborhood?
Okay, well, with that integration, AI has been augmenting what exists already. So it's just a matter of the interconnectivity. Remember, AI only gives you what you give to it, what you feed to it. So the interconnectivity of all of the inputs, augments the actual results.
Thank you so much. And Hajra will ask the next question for Dr. Kulu.
Yep. So this following question is by Gaith Tintawe, and they're asking, how do you imagine the Internet of Buildings could be beneficial in a university campus?
Okay, that's a great question. Actually, the Internet of Building can absolutely help university campus operate a coordinated ecosystem rather than a collection of separate buildings. For example, if the library became overcrowded, students can be directed automatically to an available study space in another building. Class schedules can be shared with systems like lighting systems and the HVAC one to reduce energy use in unoccupied rooms. Research buildings, for example, can share environmental and energy performance data across the campus, while solar energy generated in one building can be distributed in facilities with higher demand. So during emergencies as well, I believe that buildings in this case, they can exchange the occupancy and safety information in real time. And from this point of view, we can see that we can improve the campus-wide response to and resilience, of course.
Perfect. Thank you. And I'm going to pass it back to Michelle.
Fantastic. Really good questions coming in. Our next question is for Dr. Yusra. And the question is, as a professor pioneering AI for sustainability education at your university, how do you design learning experiences that connect abstract machine learning concepts to real environmental challenges students can see and feel in their communities?
Oh, excellent question. Thank you very much. The way I have personally been doing it, I introduced what I call publication-based learning. So the machine learning and the data analysis classes in which we tackle environmental and solutions for sustainable solutions. I try to do it within collaborations with the local agencies, for example, the local agency for water and fish preservation. We have been working with them for several years now. And other NGOs, for example, for people with disabilities, for instance. And therefore, the students work within the framework of a real need, and they speak directly with the domain experts. And from that, they draw the design of the solutions, and then we deploy it, and then we can have testing in the real case studies. Thank you.
Thank you so much. And I'll pass it back over to Hajra for the next question for Eric.
Perfect. This final question is also by Dr. Indira. She's asking, Imagine Studios positions itself at the creative frontier of sustainability and technology. What does the creative imagination bring to sustainability challenges that purely technical or policy-driven approaches miss?
All right, so creative imagination allows us to visualize features that do not exist yet. And this helps communities, businesses, and government to see sustainability not as sacrifice, but as opportunity. Through storytelling, art, design, media, and immersive experiences, we can make complex issues like climate change, biodiversity loss, and renewable energy and circular economies tangible and relatable. Thank you.
Thank you so much, Eric. And I just want to make note of the QR code that is up on the screen right now. This will allow you to take the quiz for today's session and then receive a certificate. So we highly encourage you to download this QR code and go ahead and go through that process. And if you have not had the opportunity to take the prior sessions, you are welcome to go back at any time and go through the programs, take the quizzes, and receive your certificate for those sessions. We're not sure how long they will be up, so we really encourage you to do it as quickly as possible because we want everyone to receive the full certification program. And I know that we are just on time now, and we want to be super respectful of our audience. As well as our speakers and everyone involved. We know this is always a long session, but we also want to say that if you have asked questions that we did not get to today, that we encourage you to keep an eye out from all of our speakers to answer those questions on LinkedIn, because we want to keep the conversation going as long as possible. And then also, if you do receive your certificate, we encourage you to share those online. And I just want to say thank you so very much to our collective team who helped to promote the program. We have Jane and Natasha, and of course, Hajra, who's with us here today. And to our speakers who just did such a phenomenal job in such an organized fashion and also answering the questions in a very timely manner, which they're very complex. So I really give you a huge credit for being able to do that in such a streamlined fashion. And to our audience for just your continued leadership. This program is not what it could potentially ever be without you. You are an integral part of it. And so we are so thankful for that. And I am going to give it back to you, Dr. Wissam, who's really brought us all together. This is such a great vision of his to have this global professional fellowship. And we're just all so honored to be a part of it.
Yeah, thank you so much, Michelle. And again, I would like to thank all the guest speakers for their interesting sharings and the audience as well for their engagements. So we'll see you next week in the module number 9. So we are getting close to the end of this program. And hopefully, as Michelle mentioned, that we'd love you all to be part of it and to complete the whole program because we are now um, finalizing the second fellowship program, which will be released right after we finish this program. And even we start thinking about the third one. So uh, we are, we might be more excited than you all, but yeah, we'll be happy to see you again next week and the week after to complete the whole program. So thank you so much and have a good time, everyone. And yeah, wish you nice times. Bye bye. Thank you.
Bye,
Thank you very
everyone.
much. Thank you.
Thank you. Bye.